Welcome, Math 20-2 to Mathematical Reasoning Lesson 2. Today we're doing deductive reasoning, or also known as logical reasoning. In this here, we're going to be kind of setting up some proofs, okay? And eventually we could use deductive reasoning to make proofs, or finally proving why things are the way they are. So you're kind of like mathematical lawyers. So here's the very first one. It says, write a conclusion that can be deduced from each pair of statements. Okay? So deductive reasoning means we use a logical process of using true statements to arrive at a conclusion. Alright? So let's take a look at this here. Every whole number is an integer. 6 is a whole number. Well, if 6 is a whole number and every whole number is an integer, 6 is an integer. The next one says, water freezes at below 0 degrees Celsius. So then the temperature is -15 outside, so then water should be frozen. Or the water is freezes. Or the water is freezing. Or water is freezing. I won't write that in. Okay, you get the point. So a theorem is a statement which can be proved using logical or deductive reasoning. Okay, so these can be proved using logical reasoning. Here is a little thing to go back on. So do you remember last class or last lesson, we looked at that one where we added 3 consecutive integers together and they always equal to 3 multiplied by the middle number. Now we're going to use deductive reasoning to prove this conjecture. So I'm going to start with n. So I'm going to start with my first n is equal to term 1. Okay, or the first integer. First integer I'll put. Okay, we're going to put n plus 1 equal to the second integer. N plus 2 is equal to the third integer. Right? Because if I put this at 1, the next one would be n plus 1. 1 plus 1 is 2. Next one would be 1 plus 2, which is 3. If I said this is 3, okay, the next one would be 3 plus 1, which is 4. And the next one would be 3 plus 2, which is 5. So those 3 consecutive integers. That's how I got that. So let's add these together. This is n plus 1 plus n plus 2 is equal to 3 multiplied by n, we're going to say. Okay, it's 3 multiplied by that. Because we want the sum of all of these is equal to 3 multiplied by n plus 1. The middle integer, okay, is equal to the middle integer multiplied by 3. So let's continue this. Okay, let's add all these together. I'm going to end up getting 1, 2, 3n. Okay, and then I add these together, plus 3 is equal to 3n plus 1. Now I look at this, I could factor a 3 out here. Right? Because everything here can be divided by 3. And there we go. So, thus, this is proven. It is true. I proved it through deduction. This shows that it is true for every single 3 consecutive integers. And we're done. Okay, let's take a look at the next one. It says complete the chart and make a conjunction using inductive reasoning. So first we're going to use inductive reasoning, then we use deductive reasoning to prove the inductive reasoning. Okay? So it's proving, deductive reasoning, prove is sometimes our inductive reasoning, or can disprove it. So here we go. Choose a number less than 10. Okay? Well, I'm going to use a simple number, 1. Because 1 is so easy to do. Add 7. So 1 plus 7 is equal to 8. Next we're going to multiply by 2. It's going to be 16. Okay? Next, we subtract the original number. Gives me 15. Next, I'm going to subtract 2. Give me 13. Then it says subtract the original number again. So give me 12. Okay. So it's 12. Now let's take a look at the next one. Choose a number less than 10. Well, let's try 2. I'm just going to go to 2. Now add 7. 9. Multiplied by 2 is 18. Subtract the original number. Gives me 16. subtract 2 gives me 14. Subtract the original number gives me 12. Well, that's kind of interesting. Okay, let's take a look at the next one. Let's try number 3. Okay, add 7, 10, multiply by 2, 20. Subtract the original number, 17. Subtract 2, 15. Subtract the original number again, get 12. So, what could be my inductive reasoning? Well, no matter what the number, as long as it's less than 10, we will get 12. Now let's try and prove that using inductive reasoning. So I'm going to choose a number less than 10. So in this case, I'm going to say n, some number less than 10. Now I'm going to add 7. So it's going to be n plus 7. Now I multiply that by 2. So that's 2n plus 7, which is the same thing as 2n plus 14. Remember, we have to multiply both. Distributive law. I'll make sure that looks like a 14 and not a 19. Okay? Now it says subtract the original number. Okay? So we get 2n, what was it? Plus 14, and we're going to subtract n, which will give me n plus 14. Then it says subtract 2. Okay, so I'm going to get n minus or plus 14, take away 2, which gives me n plus 12. Now the last one says subtract the original number. Okay, so that's going to be n plus 12 minus n, which gives me 12. And that's how we end up getting that. Okay, just put that brackets. So we're subtracting n and we get 12. So in here we subtract 2, so in here we subtract n, and go like that. So we have proved that whatever the original number is, our final answer is always going to be 12. Does the original number have to be less than 10? Well, I didn't say n is less than 10. I could have put 50 there, right? Because n could be 50. We have no restrictions. So no, it does not. Comma. It can be any number. Okay, so it can represent, n represents any number. Okay, so no, it cannot. N can be any number. All right, let's take a look here. Example number 4. It says, so now we're going to look more at this. So we always put 2n where it's even numbers, because 2 multiplied by any number is even. 2 multiplied by 3 is 6. 2 multiplied by 4 is 8. It doesn't matter. If you double it, you're going to have an even, right? It's like 2 groups. No matter what, you're going to have equal groups, you're going to have even. Now if we have 2 equal groups and I take away 1, there's an odd man out. There's going to be one person without a partner. Okay? If we have 2 groups and they're even, or 2 groups and there's equal amounts in each one, doesn't matter if it's odd or even, combine them together, everyone will have a partner. One person from each group will have a partner. If you take away one person from those 2 groups, one person won't have a partner, that means it's going to be odd. Or we could go plus 1. So, explain why 2n can donate every even number. Because every even number can be divided by 2. 2. Okay? Or every even number is a multiple of 2. Okay? Now, where 2n, okay, explain why this may donate every odd number. Okay? Well, that's because every odd number is 1 less than every even. Or it's 1 more. Because think of it this way. If you have 9, if you have 10, subtract 1, you're going to get 9, no matter what, because every second number is even. Okay? Now, consider the following statement. When two odd numbers are added, their sums are always even. Use inductive reasoning, 3 cases, to suggest the statement is true. So we're going to use inductive reasoning. We add 2 odd numbers are added, their sums are always even. Okay, so we have 1 plus 3 is equal to 4. That's true. Let's try 3 plus 5 is equal to 8. And I'm going to keep still low. What about 1 plus 7 is equal to 8 as well? So those are all true. Okay, I'll even go a bit more. 5 plus 9 is equal to 14. So no matter what, it's true. We only need 3. I did a lot more. Now it says use deductive reasoning to complete the proof. So we want to use deductive reasoning to complete the proof. Okay, so 2 odds. So if I have 2n minus 1, okay, and we want to add that to 2n subtract 1, will give me an even number. Okay, oh, we'll put another one. Will give me an even number. Okay, well, let's see what this equals to here. So I'm going to have, so that means whatever this is, this number has to be divisible by 2. So if I combine this, I'm going to get 2n plus 2m, and then we have minus 2. Now I look at this, each one of these I could factor out a 2n. Okay, so it is the same thing as multiplying any odd number by 2. So that means we have 2 groups of these, 2 groups of this. So that means everyone in this group, and if they're the same groups, because these must be the same, because they're the same values, would have a partner. Therefore, it must be always even. This is a multiple 2. And even. There we go. Okay? So that's everything there. Hopefully you understood that, and I'll see you tomorrow as we work on these questions together.